This video will just cover a few of the problems on the Unit 3 study guide, particularly the ones concerning graphing, as at least this term we'll have two separate quizzes and one will only focus on graphing. So this is to help you get ready for that. Okay, so these are solving a system by graphing, so I'm going to first put my equations in slope-intercept form. Sometimes we could graph them without doing this step, depending on the equation, but for most of you I think you prefer to graph from slope-intercept form. So I move the x over, start at 2, down 1 over 1. Remember, you don't have to make this many dots, but you do need your line to be straight so that you'll be able to tell precisely where it crosses. So there is the first part. There's my first equation. And now for my second equation, I will move the x over. Hello. My negative sign went right into my equal sign. And then everything in this one needs to be divided by -1. So a lot of you already know that just means all of your signs are going to switch. So for this one, I will start at -4. And I'll be going up 1 and over 1. And so we can already see, because I followed it up enough, I can already see that it is going to cross, where it's going to cross, which is here. And then don't forget, when you're solving with graphing, not only should you have both equations marked on the coordinate plane and graphed, but then indicate your solution. So in this case, this is 3, -1. And then I can check that to make sure that it works. 3 plus -1 does equal 2. Check. 3 subtract -1 does equal 4. Check. So it works. Again, don't necessarily have to do that, but it is a good way to know for sure that you are correct. Alright, this next one, the top equation needs to be moved around to get in slope-intercept form. Again, move your x over. Alright, so I subtracted the 3x on both sides, so now he's on the right, and he's negative. Divide everything by the -5. Two negatives make this positive 3/4 x. 15 divided by -5 is -3. So this first equation, start at -3, up 3 and over 5. That's rather inconvenient. We'll say it's right there. Or down 3 and left 5. Not quite on the line, because this dot up here is incorrect. There we go. Wait, up 3 and over, that's because I did not count 5, I counted 3. Alright, so down 3 and over 1, 2, 3, 4, 5. That's why. Alright, nothing like jacking that up. Not starting over. And then the other one is already in slope-intercept form. I'll start at 4. 1, 2, 3, 4. And up to over 1 rather. Up to over 1. Down and left, down and left. Down and left, down and left, down and left. Whew. Alright, so I had to go a good ways on that one before they cross, but they do. So, let's see here. Alright, so it's coming on down that way. This point is where they intersect. So that is -5, -6. So 3, I'm doing my check. 3 times -5 minus 5 times -6, -15 plus 30 does give me 15. Check, check. And -6 is equal to 2 times -5 plus 4. Also true. Check. Alright, so this is my solution. Alright, so if you're solving a system of equations by graphing, graph the first one, graph the second one, and then give the intersection point. If you happen to have two equations and they are parallel, if they are equations and they're parallel, there would be no solution. Alright, so I'm just going to pause the video. I will make these two graphs, and I would suggest you pause it, try them, and then come back to see what my graphs look like. So I'm not going to talk you through these. I'll show you my work, but I'm not going to talk through them. Okay, hopefully for number 3 and number 4. So number 3, my solution is 8, -5, way on the edge of the graph. And for number 4, my solution is there is no solution because both of these equations have a slope of 4/3, and so they are parallel lines. And you can see what the lines look like there. So feel free to pause again if you need a moment to jot anything down. Alright, for now we're going to skip over the substitution and elimination problems and go to problems 18 through 21 on linear inequalities and systems of inequalities, because this first quiz for Unit 3 is only over the graphing sections. Alright, so very much like what we just did, we need to get the equation in slope-intercept form first. It's especially important with these inequalities to get it in slope-intercept form because it's easiest to tell which way to shade. If you know like y is greater, then y is greater means it's going up. So I move my x over, dividing everything by -3. I get y is, this is going to change to greater because I divide it by a negative. 2/3 x minus 2. So -2 up 2/3. Also could go down 2 and left 3. And this will be a dotted line, right, because it does not have the or equal line. So places along this boundary line are not actually solutions, but everything that is above the line, so we're talking all of the things above this line. And if I chose 0, 0, put 0 in for x and y, 0 is less than 6, so it should be shaded, and it is, so that's good news. Number 19 is also an inequality. In this case, it's just only an x, so this is going to be a vertical line. at -3. It is a solid line. We know that because it has the or equal to line, and it says x is greater. When we only have an x, greater would be things to the right. So it would be shading in that section of the graph. And then the last topic that we learned of the, in this unit with graphing was putting those two ideas of systems with equations and then linear inequalities together to make systems of linear inequalities. And we're going to look at two problems from that section. These problems should help you be ready for the 3A, Unit 3 Part A quiz. And this one is already in slope-intercept form, so that's nice. -2, up 3 over 1, down 3 and left, gives me the same line. This should be a dotted line, dot, dash, but some openings, and y is less. So think about the y-axis. This is at 2, the y-intercept, -2. So less would be below that. Everything below that. And then for the other one, now we're talking, again, already in slope-intercept form. Start at 3, down 1 over 1. This is also a dotted line. Dot, dot, and this shading is greater, so it's going to go up above the blue line, right? So if it's on this side of the line, it's everything on this side of the line. So the section that is blue and purple is the section that is actually the solution to the system. You could leave the just blue and just purple, but this section is the selection. That's this section. Sorry about that. That's your solution to the system. And one more. So 2 more inequalities to graph. So -y greater than or equal to -2x plus 0. Divide by -1. So everything's going to change signs, including the direction of the symbol. So this would start at 0, 0, up 2 and over 1. This will be a solid line because it has the or equal to line. And after I flip that, that is now y is less. Remember, I had to flip it because I divided by a negative. So y is less than that. So we're talking below this line. Think about that y-axis if you're not sure about like what kind of looks like to the right, but just think any point on the line, you're going directly below that point. And then for the other one, we are going to move that x over. So I have y is less than -3x plus 5. No need to do any division, no need to switch any signs. Start at +5, down 3 and over 1, down 3 and over 1, so on and so on. And this one is a dotted line. Could also go up and left. And shading is less, so it is below that line. So below. So that's everything It would also include all of this for the green, but for the solution to the system is the part that is green and blue. So if you did that IXL lesson, you would only be clicking on this, or if it was a multiple choice and only that part was shaded, that's the part you would be looking for. For our purposes, if you put both and then show me where they cross, that is great. If I can see that you have both colors there. Alright, so there you go. There were 8 problems there, similar to the kinds of things that you will need to do. I may also give you a question that asks you to determine if something is a solution to an inequality, a system of inequalities, or a system of equations, where you would be plugging in x and y and then seeing if it's true or not, which is, remember, how we could check if we're shading in the right place and if our solutions are correct. Thanks.